So for the domain of the composition that we're working with, where we have f plus g of x, we need to find the domain of the inside function. So our inside plugged in function was g of x, and intersect that with the domain of the final answer, which for us was f of g of x. So we're going to find the domain of the inside function, g of x, the domain of the final answer, f of g of x, and find their intersection, and that will be the domain for our composition, okay? So let's think about the inside function first. Our inside function was g of x, that was x plus 1, all right? So what's the domain for x plus 1? All real numbers, right. Your domain is going to be all real numbers unless you have a 0 in the denominator or a negative under a square root or a fourth root. I didn't even have a denominator or a radical, so no problems there. And then I need to look at the domain of my final answer, f of g of x. So when I'm looking at 1 over x plus 1, I don't have a radical, but I do have a denominator. So I am going to have to make an exclusion. So what do I need to exclude? Negative 1, right, because that's where my function is going to be equal to 0 in the denominator, and I can't have that. So all I need to do is say the denominator can't be equal to 0. That means x plus 1 can't equal 0, so x can't equal negative 1. So if I'm looking for the intersection of all real numbers, I exist everywhere, negative infinity to positive infinity, color in the whole number line, and all real numbers except for negative 1, so color in the whole number line, only have a hole at negative 1, just that one little spot has to be omitted. Those are going to overlap, and both of them exist everywhere except for at negative 1. Anytime you intersect all real numbers with something else, that something else will be your domain. So we look at that and we're like, okay, so how come we even have to consider that inside function thing? I mean, the domain of our composition ended up being the same thing as the domain of our answer. Well, let's look at the next one. For the next one, they give me two different functions, and they ask me to find f of g of x. So we'll start on the inside with g of x, and g of x was this radical. So let's replace g of x with what is equal to the radical. Now I have f of that radical. So that means put the radical in the place of x in the f function. So I'm going to put that radical in the place of x in the function. So put the radical in the place of x. So that would be x squared minus 9. So that's the radical squared minus 9. So that's what we've got right here, the radical squared minus 9. All right, if we take the square root and we square it, the square root and the square drop out, right? So we would just be left with 9 minus x squared minus 9. So 9 minus x squared minus 9, the 9's drop out, and I'm left with negative x squared. If I only looked at the final answer to determine the domain of my composition, I would look at that and go, no radicals, no fractions, domains all real numbers, that means this exists everywhere. Okay, try plugging 4 into that thing. If I were to go through and do f of g of 4, remember, this is supposed to exist everywhere. That means that I could put in any number on the face of the earth for x, and it would give me a real number answer for y, because I always have to eliminate undefined and imaginary, right? So if I take and I plug 4 in, g of 4 means put 4 in the place of x in the g function. So if I put in 4 right there, I'm going to get the square root of 9 minus 16. I'm going to get the square root of negative 7. I'm not allowed to get the square root of a negative. So there has to be a domain restriction here because I plugged in a number and it didn't work. It can't be all real numbers. This isn't going to work everywhere. So that's why there has to be another component to that domain. I cannot only look at the domain of the final answer. I also have to look at the domain of that inside function. So for this one, if we go back and we say, okay, to find the domain of my composition, let's find the domain of the inside function and the domain of the final answer and see where they both exist. See where they intersect. See where they overlap. So let's start with the domain of g of x. If I come over and look at this guy, I have a radical. So when we're trying to find the domain of a square root, we always take what's underneath the square root and do what with it? Take what's under the square root and do what with it? Greater than or equal to 0. Yep. So we're going to take what's underneath the square root and set it greater than or equal to 0. Domain is all real numbers except for 0 in the denominator or negative under a square root. If I can't have a negative under a square root, it can be positive or 0. So that's why we always take what's under a square root or a fourth root and set it greater than or equal to 0. Okay, so this is a polynomial inequality. Again, we saw those in section P5, and we went back through it again yesterday for review. If I have 9 minus x squared is greater than or equal to 0, the first thing I have to do is set that equal to 0 and solve it to get my critical numbers. So if we set this equal to 0, add the x to the other side, take the square root of both sides, I'll get plus or minus 3 for my critical numbers. I'm going to use those critical numbers to make a sign graph. So I'll take a number line and I'll plot positive 3 and negative 3 as my critical numbers. So once I've got those critical numbers on my number line, then remember that divides my number line into 3 intervals. I have an interval here, I have an interval here, and I have an interval here. Every single number in that interval is going to have the same sign, either positive or negative. So all I have to do is pick one point from the interval and test it. And if it's positive or negative, then that tells me what that whole interval is. So 0 is usually an easy point to pick. If I take 0 and I plug it back into the 9 minus x squared, you can see down here when we plug 0 into 9 minus x squared, we get a positive 9. I don't really care about the 9, I just care that it's positive. So when I plugged in 0, it was positive. That means this whole interval is positive. You could have picked any number in that interval and plugged it in and you would have gotten a positive answer. All right? Then you could test a point from each of your intervals, but remember we've learned that when you cross a single critical number, your sign changes. Cross a single critical number, your sign changes. So that makes it a little faster and easier to make our sign graph. We were looking for where 9 minus x squared was greater than or equal to 0. So greater than or equal to 0, is that positive or negative? Positive, right. So I want the positive piece of this sign graph. That would be the piece from negative 3 to positive 3. So that is the domain of g of x, the domain of my inside function. Then I need the domain of my final answer. So my final answer was f of g of x, or negative x squared. So what would the domain of that be? All real numbers, right, because there's no chance of getting 0 in the denominator or negative under a square root. I don't have either one of those. So if I am looking for the intersection of negative 3 to 3 and all real numbers, then my domain is going to be negative 3 to 3. And that's why the 4 didn't work when I put it in, because it wasn't in the domain. Okay? So those are our compositions, and again, like we saw yesterday, the domain really the trickiest part to those. All right, the last thing that they asked me to do with these compositions is to actually decompose a function. We've been taking two separate functions and combining them, putting them together, composing them. Now they want me to take a combined function, one that they've already composed that function. They want us to take that and they want us to break it back apart into its separate pieces. Now, I can't give you a step 1, 2, 3 of how to do this. It's really like a puzzle problem where you just kind of have to try and unravel it. It might take a little bit of trial and error, like you might have to try a couple of different things until you find what works. The only thing I can tell you that's helpful is look for grouping symbols. Because a lot of times when you take one quantity as a function and plug it into another function, it will retain some type of grouping symbol. Like maybe it'll have parentheses around it, or maybe you'll have that whole thing in the denominator under the division bar, or maybe you'll have that whole thing under the radical. So those are things that might help. So when I look at this, the first thing that jumps out at me is that x minus 2 is in parentheses. It kind of looks like that whole quantity got picked up and set inside something else. So I might try that first. It might be right, it might not, but I could at least start with that. So if I'm trying to decompose f of g of x was the inside function. It was the one that got put into something else, right? So I'm going to start with letting g of x be that x minus 2, that quantity was in parentheses. Now, when I'm doing a composition, typically what we say is put x minus 2 in the place of x in the function, right? If I wanted to undo that, then I would put x in the place of x minus 2 in the function. Let me say that again. When we're doing a composition, we typically put x minus 2 in the place of x in the function. So if you're reversing that process, if you're undoing that, when you pull that x minus 2 back out, you would put x in the place of x minus 2 to get your other function. So when I pull that x minus 2 out, if I replace that with x, I would be left with 1 over x squared as my other function. So let's try it and see if that works. If I put that back together, f of g of x, that would mean put x minus 2 in the place of x in this function. And yeah, that gives me 1 over x minus 2 squared. Maybe you looked at this and you were like, oh, I didn't see the x minus 2 in parentheses grouped. I saw the division bar as a grouping symbol. So I was kind of thinking that whole denominator, like x minus 2 squared, I was kind of thinking that whole thing had gotten put into another function. Okay, let's try that. If I looked at it as that whole denominator, x minus 2 squared, was my inside function, then when I pull that out, I got to replace that with an x, right? So if I pull that out and replace it with an x, that would leave my other function to be 1 over x. And if you put that back together again as a composition, absolutely that works as well. So there's not necessarily one set right answer and everything else is wrong. There might be a couple of different ways that you can do this. It just takes a little bit of trial and error to decompose those functions. Okay? So here is your homework for tonight on pages 116 to 117. Pages 116 to 117.